Hello class, right now we're going to be doing a quick little tutorial on how to go over equivalent proportions. So let's start off here. Let's just do a little bit of a review. So do you guys remember way back when, this is probably going all the way back to like second grade. Do you guys remember about reducing fractions? Let's think about it like this, right? If we have the fraction 4 over 8, we could reduce this, right? We know it's not in its most simple form. So we could say that this is equivalent to 1/2. And why is that? Well, because both of these numbers here share a common factor, right? They both share a common factor of 2. Now, what's that mean? It means 4 is divisible by 2, or 4 divided by 2 is equal to 2. And then it means 8 is divisible by 2, right? So 8 is divisible by 2, which would be equal to 4. And I guess I probably should have written this differently, right? I skipped a step here. So we should say that this is equal to 2/4. And then we'll again say that 2 and 4 share a common factor, and this is equal to 1/2. Now, of course, we could have made this skip right here to immediately go to 4/8 being equivalent to 1/2 by saying that 4 and 8 share the common factor of 4, but we'll just show this in a few more steps here. So just like we can work backwards with common fractions here, right? Because we could do anything. We could do 10 over 100. We could say that these share a common form of 10, or a common factor of 10. So 10 divided by 10 is obviously 1, and 100 divided by 10 would be 10. So 10 over 100 is equal to 1 over 10. So these are equivalent fractions, right? We know this because we're reducing them, but it can go the same way. We could go backwards. I could say, for example, 1/10 is equal to 10 over 100. And while this is clearly the most simple form because it is written with the common factors there, and you cannot divide 1 divided by 10, this right here is pretty useful because what does it show us? Well, it shows us a ratio where the first number is being compared to 100. And what do we know about a ratio being compared to 100? Well, it's a percent, right? So whenever we have a number written like this where 100 is in the denominator, we know that we could write this as a percent or 10%. Now, obviously, we could have done division from this, right? We could have done 10 divided by 100, and that would, of course, given us a 0.10, which we could have converted to 10%. But notice what this is, right? 10 over 100, we know that we can take our 10 and simply put a percent sign behind it because it's a ratio where the second number or the first number is compared to 100. And think about it. All we're doing basically is we're skipping this here step in the middle where we go from 10, 0.10 to 10%. Where actually what we're doing is multiplying by 100. So allowing us to write it in this fraction form allows us to skip that percent. So we can think of it like a circle, right? Think of it like a circle. We have a circle here and we're starting with different numbers. So we could say that we have 10 over 100. But maybe we got to 10 over 100 by reducing the fraction 1/10. Or maybe we got to there by reducing the fraction 2/20. And from that point, who knows? We could have come from a different step in between here, or we could have come immediately from the 10 over 100, right? There's plenty of different rotations in this circle, but the point is we don't know where it stops. So in a reducing fraction, we need to be able to go back and forth between these, whether you're moving from 1 over 10 to 10 over 100, or from 10 over 100 to 1 over 10, and moving in the reverse direction on this circle here. So since there's plenty of ways to do this, that means we can use a tool for it, or we can use it to help us solve these percent problems we've been doing. So if we remember back, we could go to the equivalent proportions, right? Remember when we were working over on things like this, 10 over 100 is equal to our part over our whole. So this is just another way we could solve these problems here. And I want to remind you all that you guys can use whatever way you want to solve these problems. So what's interesting about these is when we're saying they're equal, we're saying they're equal fractions, right? We are saying these are equal fractions. They're equivalent to each other. Basically, I could reduce this number over here, my part divided by my whole. I could reduce this number over here, and I could make it like this percent number, the something over 100. Or I could do it the other way. I could reduce my something over 100 and I could make it the part over the whole. But basically what we're doing is this number right here, which is always going to be our percent because it is a number, a ratio where the second number is compared to 100. This is going to be a non-reduced or a expanded fraction of our part over our whole. So let's go into using these problems here. Using our equivalent fractions to solve these problems. So we want to find out what percent is 56 out of 88. So obviously, since we're always going to have this part here, something over 100, since it tells us what percent, we don't know that, I'm just going to fill that in with a little percent sign here. That's going to be our variable. I'm not using a letter for a variable this time. I'm going to use a percent sign. Don't worry about it. It just means it's something we don't know yet. And then we have is 56 out of 88. So it says 56 out of. Anytime you hear something like out of, that's how you know that number is going to be the denominator, and 56 will be your numerator. All right, so now we have an equal fraction here. Or sorry, now we have equivalent fractions. So you could do this in two ways. You could find out what number you need to multiply by 100 to get to 88, and then you could multiply 56, or rather divide 56 by that same number to get back to your percent. Or we could simply cross multiply here, and that's what I'm going to do. So to cross multiply, you multiply your denominator times the numerator on both sides here. So first off, we have 100 times 56. Well, 100 times 56 will obviously give you 5,600. I can do that one there in my head. And then any number times a variable is just that number with that variable following it here. So this reads 88 times for the percent sign here. I should really write that in because otherwise it's a little confusing, huh? All right, so now to solve this, we are just going to do some algebra. So to solve through this here, we need to divide both sides of our equation by 88, because since we're multiplying by 88, we need to do the opposite, and the opposite of multiplication is division. So 5,600 divided by 88 would give you 63.63 continuing. 63.63 continuing, and that's equal to our percent. So what percent is 56 out of 80? That means that 56 over 80 would be equal to 63.63%. And if we want to go back into our original problem up here before we did all this cross multiplying stuff, we could say that the fraction 63.63 continuing percent is equal over 100 is equal to 56 over 88. These are equivalent fractions here. All right, so that's when we have our part and our whole, but we don't have our percent, but we can do different ones, right? What if we have our percent but not our part? So we have 48% of 200. Well, again, we're always going to have something over 100 is equal to something over something. That's not changing. Clearly, we have a percent sign here, so that one's easy. Whenever you have a percent sign, that'll be the number going over 100. We have an of 200, so an of would tell us that this is going to be our denominator, and this obviously will be our variable. So now we need to find out what fraction 48 over 100 is equivalent to the fraction x over 200. So clearly we could see that to go from 100 to 200, we need to multiply by 2. So to go from 48 to x, that means we also need to multiply by 2. So I'm just going to do this as a guess. 48 times 2, well, 8 times 2 would be 16. 2 times 4 would be 8, plus another 1 would be 9. So my guess here is 96, but let's try that out. Put a little on the side here, and we'll remember, okay? All right, let's also do cross multiplication. So 100 times x is obviously 100x, and 48 times 200 will give us 9,600. All right, we'll do some quick, simple division here. We'll divide both sides by 100 because division is the opposite of multiplication. And 96 divided by 100 is, of course, 96% here. So that means that what is 48% of 200? That would be 96%. Or sorry, excuse me. What is 48% of 200 is 96. This is not a percent right here. I apologize, guys. So basically, what are we telling us again? Let's go over it. We are saying that the fraction 48 over 100 is equal to 96 over 200. And these both can be represented as a percent as 48%. All right, everybody, that was our equivalent fraction. So good luck on those next two problems. Good luck on them.